Okay, so before we cover this part, we just went back and rewatched the video so we didn't lose our bearings. And what did the video tell us? What's the special thing about e to the x?
Well, it turns adders into multipliers.
Okay, e to the x. E to the x. E to the x turns adders into multipliers. That's still a very hard thing to understand.
Yeah.
Yeah. So, let's see if we can make any sense out of that. Okay. So, let's look at what we would do with the adder 0. Okay. What does the adder 0 do to the plane?
Well,
It does
it's just
nothing.
nothing.
It does nothing to the plane.
Yeah.
Okay. So if we wanted to turn the adder that did nothing into the plane, what multiplier does nothing to the plane?
Well, 1.
1.
Why?
Because if you multiply anything by 1, it just is the same.
Okay, interesting. So if we're going to turn adders into multipliers, it better be the case that 0 turns into 1, because
Yeah.
0 as an adder does nothing to the plane,
Yes.
and 1 as a multiplier does nothing to the plane. But now we have a little bit of a strange situation. Okay. We learned that this multiplier here, I, does what?
Well,
It shifts, well, as an adder, it shifts the plane up and down. As a multiplier, it rotates the plane.
Interesting.
Well, what can replace that?
As an adder, it shifts the plane up and down. As a multiplier, it rotates the plane. Okay? Alright, so that's interesting. And if I apply this twice as an adder, what happens?
Well, it'll shift the plane up to I.
Okay, it shifts it up to I. Interesting.
And then it'll rotate it. And it can rotate it with the circumference of 2i, with the radius of 2i.
Well, that's interesting. So if I apply the multiplier twice, what happens? When I multiply the first time, what does it do?
Well, it gets from I to 1. Or I to -1.
Okay,
Pointed right, but I said the wrong thing.
alright,
Then again then it'll go to -I.
okay. And we're just looking at what happens to the point I here.
Yeah, this is the path of the point I, and then it goes to 1.
Okay, so the one thing we're seeing that's interesting and different in the complex plane is that I seem to have multipliers that rotate,
Yeah.
but I still have these other multipliers out here that stretch. Like if I multiply by 2, it stretches. Okay.
Looks like maybe if you have like a point here, like 2 plus I, it would stretch and rotate the plane.
That's exactly right. Although it stretches and rotates in a strange way. That's what I was talking about at the end of the last video. So you figure out how far away it is from 0,
Yep.
and that's how much it stretches by. Remember we had the square root of 13? And it
Yeah.
stretches by that much, and it rotates through an angle like that, whatever this angle is.
Yeah.
So we're starting to look at angles in geometry. And later on, much later on, in a subject called trigonometry, we'll study how you actually calculate these angles.
Interesting.
Yeah, interesting. So, because we have these new multipliers that rotate, what they said in the video is if we're going to take adders and turn them into multipliers, the imaginary ones probably turn into rotations. And that's one of the things that kind of gave me a little bit of something to think about in this video. Because I said that's a very natural way to think about it.
Yeah.
Does that seem natural?
Not really.
No, not really. And that's because it's not really natural.
No.
It took people a long time to figure this out. So this is named after Euler. E to the pi equals minus 1 in the 1700s. So this is people have only understood this for a couple hundred years.
Wow.
So I'm not sure how natural it is. But they said it does it in a natural way. And it means it takes this line, the imaginary axis, and it turns it into circles. And the most natural way to think about those circles is you keep the circumference the same.
Yeah.
Okay, so that means that if I have a radius of 1 here, this circumference here is pi I. Sorry, the circumference is pi, so if I go up pi I, the exponential function should turn this into a rotation that goes halfway around the circle. 0, remember we said 0 went to 1?
Yep.
I, well, pi I, go pi around. So pi I goes to minus 1. And that's what they're talking about, and that's I don't know how natural that is, but it's interesting.
Yeah.
But it's interesting. So what do you think?
Interesting.
Yeah. Cool project.
Cool project. I think the neatest thing about this, and the neatest thing to understand, is this multiplication idea. That when you multiply by a complex number, it turns into a rotation.
Yeah.
And so I can ask you, like, 2 plus 3i here. I drew it wrong, but you can imagine what I mean. That's the square root of 13, and then it has some angle. And any number I multiply by stretches out by the square root of 13 and rotates by that angle. It's pretty cool.
Yep.
All right, good work tonight, hun. Good work tonight, hun. Thanks for going through that video.